Okay, hello everyone. This is Dr. Gallenstein. Welcome back. Today we are going to we're going to kind of start the next topic, if you will, the next set of notes. We're going to look at demand functions. Okay. Kind of the trend in the course to kind of bring us up to speed. We've started the course by looking at the decision making of rational agents. We've captured preferences via the use of a utility function. We've talked about how individual agents make their decision making by maximizing their utility. We've done a couple of applications of that, and we've looked at some decision making in different contexts. We kind of applied that to a couple policies. But what we're doing in kind of a bigger picture is we kind of go through the foundational concepts of microeconomic theory. Is that we are initially we're kind of doing the consumer side or the personal side, so individuals. And then eventually we are going to get to the producer side. So we're going to the producer side of the economy. And we're kind of working our way up towards having the microeconomic theory foundation for your typical kind of supply and demand curves. Okay. And so what we're going to do today is we are going to take our understanding of the economic decision making of individual agents, i.e. consumers, and we're going to translate everything we've talked about so far into the demand curve. The demand curve that you're familiar with from kind of standard economic theory, supply and demand. Okay, so we're building our way up to that. In part one of the course, we're aimed towards understanding the decision making of individual agents. And in part two of the course, we're going to look at how markets work when you put the two sides of the market together. So we're going to have the demand side, and then we'll have the supply side, and then when we get to part two of the course, we're going to talk about equilibrium. That means how do these two parts go together? All right, that gives you kind of the bigger picture. So with all of that said, the next place that we need to go is to talk about demand. All right, so demand is kind of the behavior or the demand for a good is kind of the consequence. It comes from consumers' preferences. So demand functions kind of come from consumer the preferences and consumer decision making. Okay, so then what we need to do is take what we've learned so far, that is kind of this utility maximization framework. All right, we need to take what we've learned so far and we need to bring it into a demand function. We need to bring it to the next step and talk about demand, market demand. Okay, so we're going to do that today. In this lecture, we'll kind of just do kind of some starting concepts, introduce it, and then we'll go into some more detail in the next lecture. All right, so let's go ahead and jump right in. Where do demand functions come from? Well, let me do a quick recap. So let's say that we have a utility function. So let's look at standard decision making. What an agent does. All right, first, let's assume that we have two goods. We have good 1 and we have good 2. In previous lectures, we always talked about coffee and bagels. So maybe we'll keep coffee and bagels. That's fine. Or maybe should we pick something different? Let's just do coffee and bagels because I don't have anything else in my mind. All right, so coffee and bagels. All right, so what we want to do is we want to say that agents are they are choosing the number of cups of coffee to consume and the number of bagels to consume in order to maximize their utility, subject to their budget constraint. It's coffee times coffee plus the price of bagels times bagels. Okay, so this is fundamentally what agents are doing when they are making their decisions about how much coffee to buy and how many bagels to buy. So this maximization process results in C star and B star. This is optimal cups of coffee, optimal bagels. C star is a function of the parameters I, PC, and PB. B star is again a function of the parameters PC and PB. And what these functions give us, what C star and B star are, is that these are functions. These are functions that tell us the quantity of C and B that the agent will consume. Will consume. Okay. Well, so the first step here in kind of deriving or knowing where demand functions come from is just to acknowledge that these functions right here capture demand. These are, in a sense, individual demand functions. This C star and this B star communicate to us how many cups of coffee and how many bagels the agent will demand. Now, typically a demand function, if you remember from thinking about, from taking up Principles of Micro class, typically you have a demand curve and it's plotted with price against quantity. And so a demand curve is relating price and quantity. And so really all we need to do to translate these into being demand functions is just to kind of rethink the way that we think about these functions. So let's just do that. So I'm just going to rewrite this. I'm going to say that C star is equal to a demand function that is a function of the price of coffee, and it has parameters, the price of bagels, and income. B star is equal to a function, I'll call it D, let's see, DC, DB. So this is the demand function for coffee. B star is equal to the demand function for bagels as a function of the price of bagels, given the parameters, the price of coffee, and income. So literally, these are our individual demand functions. Individual demand functions. These are our individual demand functions. This is the demand for coffee. This is the demand for bagels. So the demand for a good, that is how the quantity of cups of coffee, the quantity of cups of coffee demanded as a function of the price of cups of coffee is literally the function that we solve for when we do the utility maximization process. The utility maximization process gives us the demand function. This is a function. It is a function that has the variable, the price of coffee, and tells us how many cups of coffee they will demand given that price of coffee. So this is a demand function. So when we solve the utility maximization, what we get, when we have C star and B star, what we get are demand functions. We just have to kind of rethink about them conceptually. Okay, let's go to the next step. So what we do is if we want to get a demand function, we solve a utility maximization problem. We solve the utility maximization problem. That captures individual preferences, and so it captures how much, basically the quantity of each good that is demanded. So C star equals the demand function for coffee as a function of the price of coffee, taking the price of bagels and income as parameters. B star is the demand curve for bagels as a function of the price of bagels, taking the price of coffee and income as parameters. Now, graphically speaking, what we typically do, so these are demand functions, what we typically do is we graph the inverse demand function. So this gives you what we're familiar with: quantity on the x-axis, price on the y-axis. This is the demand curve that you're familiar with from Principles of Micro. This is actually what we call the inverse demand curve, because it is a function that gives the price as a function of quantity. So it's just the inverse. So the inverse demand curve would be the price of coffee as the inverse demand as a function of the quantity of cups of coffee, taking the price of bagels and income as parameters. These are the inverse demand curves. So if I wanted to plot the demand for coffee, what I would actually be plotting is the inverse demand. So that's this function here. So if I wanted to plot the demand curve, what I do is I plot the inverse demand curve. That is a function where price is the output and quantity of cups of coffee is the input or the variable. So this is the inverse demand function. It takes coffee and tells me the price. That's the inverse demand curve. Okay. All right, so now let's go deeper into this graph. We're very familiar with demand curves from Principles of Micro. So let's go a little bit deeper into this graph, and we'll gain kind of some deeper insights into where this graph comes from. Oops. So I'm just going to draw, what I'm going to do here is I'm going to draw two graphs, and we're going to gain some deeper insights. So what this is going to be is I'm going to do, the top graph is going to be familiar to you. It will be the graph of the two goods in our illustration. So it will be, let's do coffee here and then bagels. Okay. And then this is the price of coffee and the quantity of coffee consumed. Okay, so on this graph, on the top graph, we can have a budget constraint. Switch over to stroke eraser. Okay, so here we can have a budget constraint, and we can have our indifference curve. And so in this case, people will choose the bundle. We'll just call this the bundle capital A. Okay. And I'm going to use this illustration here, these graphs, to illustrate the demand function. Okay, to illustrate the idea behind the demand function. Okay, we're just going to illustrate it graphically. Okay, so up here on the top graph, we have kind of our standard graph that plots two goods, the budget constraint and the indifference curve between those two goods. And so we have this optimal bundle A that tells us the quantity of bagels and coffee consumed, given the prices that correspond to this indifference curve. So that's the indifference curve. I'm sorry. It's not an indifference curve. This is the budget line, and I typically use L to represent the budget line, so let me do that. So budget line L, this corresponds to some budget constraint. That is, it corresponds to some value of of the parameter income and the price of coffee and the price of bagels. Okay. All right, so now if we want to understand the demand function, remember kind of our standard demand function relates price and quantity, and it's downward sloping, right? So that means that the higher the price, the less that I demand of that good. The lower the price, the more of that demand, more of that good that I demand. So if the price is really high, let's say it's way up here, then I will demand very little. If the price is very low, I'll demand much more. Okay, so we have this downward sloping relationship where as price increases, the quantity demanded decreases, right? So there's this inverse, this negative sloped relationship. We could even put this in terms of a derivative. It's easier to think about it the other way. All right, that this is going to be negative, downward sloping. Okay, negative relationship between the two. All right, well, what I want to do is I want to illustrate using these two graphs. I want to illustrate this downward sloping relationship. All right, and I want to relate it to what we've already been looking at when it comes to preferences. So this is what I'm going to do. I'm going to say, let's assume that that the price of coffee. So here, this dark blue line has the price PC. Let's assume that the price of coffee decreases from PC to this light blue PC. All right. So now we have this light blue budget line, and it corresponds to this. The income level is the same. The price of bagels is the same, but the price of coffee is now decreasing to PC. So PC is less than PC. So I'm using the color to distinguish between them. I hope you're following me. So what has happened is that the price has gone down from PC, from the dark blue PC to the light blue PC. Okay, and so if the price goes down, that means that we are able to afford more goods. Our budget line shifts out. That means given the same amount of income stays the same. Given the same amount of income, I can afford more coffee and bagels because the price of coffee goes down. And so this budget line shifts outwards. One way that we can represent this is if we look at what the intercept, at what value the budget line intersects the x-axis. This would be where bagels is 0. So here C equals I divided by PC. And so if PC goes down, then C will go up. Okay, so if the PC goes down, then this intersection point will change to I divided by PC. And so actually, if I want to be consistent with my notation, here, I'm going to use the dark blue I. Income stays the same, but now the price goes down, and so this shifts out. The budget line shifts outwards to accommodate now this lower price. Okay, so if the price of coffee goes down, what's going to happen? You know what? I'm gonna change this a little bit here. Oh, whoops. Just want to give myself some more space. All right, so this is point A. So what's going to happen here is that now that the price of coffee went down, the budget line shifts out, and now they're able to afford a bundle and a higher indifference curve, which I'm going to represent with this dark B. So here's an indifference curve. And so now they're going to get bundle. Now they're going to get C star. Sorry, I get my colors right. Okay, so now they're going to get some bundle B. And bundle B is going to have a higher quantity of bagels and coffee. And the reason that it has more is because now coffee is cheaper. And so the same amount of income can buy them both more coffee and more bagels. Okay, so now I just want to relate these things down to the demand curve. So what I'm going to do here is I'm just going to take these values and I'm going to draw these lines down into this other graph, and it's hopefully going to help us relate these two concepts together. So let's use orange. All right, so at point A, the price is, let's say, so the price at point A is equal to PC. And then point B, the price goes down to this light blue. Okay. And the quantity of C consumed is lower. Let's use our colors here. C star. C star. So what we have that when the price is higher at this dark blue PC, the quantity of coffee consumed is lower, so it's here. But as the price goes down, the quantity goes up. And so what we see here is that we see a downward sloping trend in the demand. And if we kept going, this isn't the best demand. Let's try this again. If we kept going, if we kept reducing the price of coffee, and we could even do it again, we reduce the price of coffee again, drawing another budget line L, where the price of coffee is even lower, what we would end up getting is we would get another indifference curve that has more coffee, and we could chart this down here, where the price is even lower. The price is all the way down here, PC, and so the consumption of coffee is even bigger up here at C star. And so what we get is we get this downward sloping demand curve. So we can see how the demand curve goes down as the price goes down. So as the price goes down, from blue PC to light blue PC to purple PC, as it goes down, as it decreases, the quantity of coffee goes up, as you can see here from the optimization process, and these will correspond to this downward slope in the demand curve that you see here. All right, so this is where the downward sloping in the demand curve comes from. It derives from the preferences. So this graph here kind of represents preferences. And then this graph here shows demand. And so what this does is it relates how preferences determine the downward sloping nature of the demand curve. So as price goes down, consumption goes up. That derives from the underlying preferences, which we have already looked at in the course. Okay, so that's just an introduction on demand functions. We'll come back in the next lecture, and we're going to start to talk about how changes in income and changes in prices will affect demand. But for now, we'll stop here. Thank you. Have a great day.